Awesome. So before we begin, a huge shout out to all of you who are believers in open source, proponents of open source, ambassadors of open source, and evangelists of open source. And also a huge shout out to Eclipse Foundation for having us here and having this happen. So my name is Bharath. I'm here to talk about a dystopian topic, if you may call so. It's about building a greenfield smart factory powered by open source in 2023. So my co-speaker and my friend Joey is unfortunately not here. But then Joey and I have been working for close to a decade building smart factories. So we have culminated some of our knowledge and our experiences working on this field, and we want to share this with you today. All right, so building a greenfield smart factory. So why do I say greenfield? Because you guys know factories have been existent over the past, and they've been gradually building upon what they already have. And the ecosystem there is pretty heterogeneous with a lot of vendor lock-ins, a lot of closed source products, and so on. So that's where we took this topic of what happens if we build a completely brand new factory on open source starting from ground zero, right? So this would help us in the way of having the latest and the greatest in terms of technology, in terms of providers, in terms of, say, the available, say, communication parameters as well as we build the factory, right? So the background of this slide is probably the iconic Windows XP wallpaper, my first computer, but I just use it to show the green field here. So we are just starting with a green field ideologically, and then starting from there, right? So the vision here is to embrace circular economy. I mean, we are at a stage where we want to make sure we have ecosystems that support the future generation. So we want to make sure we are producing responsibly, consuming responsibly, and then giving back to the next generation responsibly. The second one would, again, corner around the topic that is of great importance today, ESG, sustainability, and so on. So we want to minimize environmental impact, and as we saw from today's keynote on sustainability, I think open source has a greater impact on sustainability, and we'll also see how and why. And the last one is optimize resource utilization. So we do not want to reinvent wheels. Wheels have already been there. We just want to build cars and other things that can use the wheels to run, right? So that's the overall idea. And what I also realize is the Eclipse Foundation, like other open source projects, have a lot of work that has been done as part of the community. Then what if everything comes together to form a single most powerful smart factory that can be probably a model factory on which new factories can be spun upon? So that's the overall ideology. Right, so this is the background that I talked about. So we start with three things. We talked about why, that's the vision part. Now, what is a greenfield factory? So what are the major building blocks? So in my experience, if we have worked on commissioning greenfield factories, it has taken anywhere close to 3 to 4 years from start to end, including, say, civil construction, networking overlay, device installation, process installation, application installations, and so on. So it's a tremendously long process unless we are Tesla and then we spin off gigafactories in a year from ground zero to production. So the idea is we look at greenfield factory in multiple components. I am zooming out on a very high level. So as I said, let's start from the scratch. So let's look at what constitutes a greenfield factory, what do we build with that, what are the components at a very, very high level. So everything starts with planning. So we have a digital strategy that says, okay, we're going to build a particular product or a process or something is going to be manufactured. So that's the strategy part. Then you have the engineering team that works on actual engineering design, what needs to be manufactured and how it needs to be manufactured in terms of process. And then you also have the product lifecycle management and the tools that enable them. Then comes the actual manufacturing of the site, the civil construction, where you build the facility for manufacturing. So we'll talk about it later. On the left, you have the logistics, because you need to talk about the materials that come in, and then we also talked about fleet management in the previous session. So all of this are part of the supply chain and transportation, so that form the logistics block. Then you have the materials block where you take care of incoming materials, storage of those materials in your warehouses, then making sure you have materials available just in time for your production. So that's the materials block. After which, the basics of manufacturing is that you have order management systems that says what needs to be produced today, depending on your market need, depending on how you want to sell, and depending on what is actually selling. Then you have the actual production, where you convert, say in process industries, you generate new products by combining multiple products, or in the discrete manufacturing, where you manufacture a particular component, assemble a component, and deliver a new product. So that's the production. Then you also have the workforce, because at the end of the day, manufacturing is a combination of people, process, and technology. So people are relevant today in the field of, even though we have robotics, I think workforce management and making sure human beings are also involved and form the core of the component is really important. So that's the major three pieces. I mean, there are so many pieces that we can talk about, but I'm just highlighting the top pieces of the construct here. So after the manufacturing is done, we take care of quality. And quality, as we know, is full cycle. It starts from design until end of life, even when the product is in the market, running at somebody's place, and so on. So you have quality assurance and safety. Then you also have packaging, which takes care of actual shipment of the product, the reverse supply chain, where the finished goods are shipped from the factory to the warehouse, to the distribution center, to the end user, right? And then you have the maintenance that takes care of maintenance of every component here, the manufacturing machines, the processes, the supply chain, the fleet management, everything comes under maintenance. Then you also have security. Security also is a full circle, so all of them are interconnected with each other, and that's what we would say when we talk about how data gets connected as a fabric which weaves around each of these blocks. So we have physical security that takes care of perimeter surveillance, your safety of your equipment, safety of your assets, and so on. And you also have asset security that takes care of data as a security component. Then you also have utilities, which are the facility management, the energy treatment plant, the effluent treatment plant, the wastewater treatment plant, the sewage treatment plant. So all of this come under regulatory compliance that also need to be taken care. And finally, we have the core components of manufacturing that we're going to talk about today. That's everything in the green. And then you also have the developers. That's where I think most of our work comes in at the bottom. So in manufacturing, we're going to talk about network, data, and infrastructure. And then applications that go on top of that, that consume these services, right? And the development and operations piece is where we have the DevOps, DevSecOps, DataOps, MLOps. So all the things that help in pushing applications, pushing updates to the field, to the manufacturing entity, to the edge, to the cloud, to any entity that you take care is coming under development and operations. So what you see in blue around is the support functions, and what we are going to talk about today are in green, the core functions. So we will be focusing on each of them and then trying to ideate if each of them can be replaced with an open source component and how all of them would tie in together to form a smooth working engine for us. So this is a sample architecture that is constructed from, say, combining multiple standards, say the ISA 95 standard, the Purdue model, the unified namespace model, which is a radical shift in terms of how we look at data as a connector between various entities. So at the bottom, you have the OT production network, the manufacturing entities there. You have the PLCs, the sensors, the machines, the SCADA systems, and so on. On top of that, you have the edge compute, where I think that's where we are also moving towards in terms of focusing on sustainability. So if you're able to take edge-dependent decisions and not send everything to cloud, just like the previous speaker talked about, right? So if you're able to take local intelligence, make work for you, I think that's the best case scenario where you're able to look at, say, rapid decision making at the edge. And then you can look at, say, final data that can be archived and so on. Then you have the demilitarized zone. I think this is where is getting a lot of prominence because there is a clear separation that is needed for OT to IT. But then when we talk about Greenfield, we're looking at systems that are really secure, that can be secured, that are not legacy, and they do not use, say, unsecure protocols and so on. So given that we have this assumption of building this from scratch as a greenfield plant. So we have this demilitarized zone that is responsible for data collection, data transfer from OT to IT, and also taking care of monitoring the entire thing. So how does your network look like? How does your data access look like? How many people come in to access your data via remote access, and so on. So that's the DMZ layer. Then on top of that, you have the cloud compute layer, and then you have the user applications. So on the right, so this block is what we call as the unified namespace. It's called as digital service bus. It's called by multiple names, but the major crux here is in the ISA 95 model, each layer was hierarchical in the sense data used to go from one layer to the other. And then we also talked about the cloud and the edge model where data used to go to the edge and then to the cloud. And now what we are changing right now is any layer, any system can talk to any other system independent of the layers in between. So that's the data conduit, which is called the message broker, and this is where MQTT has been a real game changer for us in terms of the ability that it provides for us to exchange information from point A to point B in a very simplistic manner, right? So this is the unified namespace. And on the right, you have the actors or the stakeholders who are really important. I mean, they play a major role, and each of them look at the same data, but then they make inferences differently. For example, our CIO can look at production data, and then he can look at production metrics, and then look at how it balances out in terms of financials. But then a plant manager is looking at the data, looking at what's his plant output, what is his production efficiency, and so on. Whereas a maintenance engineer can look at data in terms of how his assets are performing, when was the maintenance done, what is his worker efficiency, and so on. So these are the actors and assets that are consuming data, but at the same time, they make sure they create the value using the applications on the top. So these are the major applications that we have worked on in terms of the value add, in terms of return on investment. I think we've been talking about a lot of cool new features that have been coming, but what actually adds value in the field, in the smart factory, is something that we have listed on top, starting with production performance, maintenance, optimized operations, where you say how do you schedule your shifts, how do you increase your overall equipment efficiency, and so on. So these are the applications that are here. So the major crux is with this architecture and the previous slide that I showed you. So we're going to talk about how open source fits in here, and then how everything comes together, right? So so coming back to this slide, so this is the architecture based on unified namespace, and these are the core components that we're going to talk about: infrastructure, data, network, and application. Right. So again, a quick disclaimer. So these are recommendations based on what I have and my team has worked on. So it's not affiliated to any, nobody has sponsored us or nobody has given anything. So what has worked for us, what we have already experimented with, is what we are going to showcase here. I mean, please, and there are multiple alternatives as well, right? So even if you look at the Eclipse IoT website, there are 45 projects, and all of them can perform the same task for you. But then these are things that we have actually tested and worked with that can actually help you kickstart this entire ecosystem for us. Right, so I'll probably use my mouse to show you around. So starting with sustainability, so we have been using this product called OpenEMS. So I'll tell you a quick story on this. So this is a energy management system software, which is, again, open source. But then when we started to work with a customer who wanted to get them certified into ISO 50001, we had this huge challenge where there were proprietary protocols, energy meters were not getting connected, the charging systems, the generators, all of them talked multiple protocols, and they were not working together. And I think these guys have done a tremendous job to pull everybody in. And then it was a breeze to set up a system where we were not only looking at energy data in an instance, but also look at demand management. How do you look at energy procuring, energy brokering, and so on. So there was a request from a client where they could actually pre-purchase their energy demand if they're able to estimate it correctly. And this was a basis on which we were able to estimate energy consumption for a future period of time, depending on historical usage, current demand patterns, and so on. And that saves a lot of money. For each unit of power, if you're able to, say, pre-book your power, you are actually saving, say, 10% of your actual energy bill, which is a great saving at the end. Right, so this is on the sustainability front. On the security front, I specifically want to talk about OpenEDR and Bloodhound. I'll probably share this map with you guys, and you can also use it in the future. So each of them is hyperlinked and so on. So we've been using multiple tools to do hardware penetration testing because OT cybersecurity is really not very well known as IT cybersecurity, because most of the ransomware attacks that happen in the OT space are pretty dangerous in terms of business continuity, business reputation, and also loss of lives, loss of production, right? So that's why I think it's really important to make sure, sorry. It's really important to make sure we deliver products that are really secure and really robust and are tested securely, right? So that's where I think it also raises an important question of when we use open source, what's the credibility of the entire project, entire community? I think there are tools that have come up. We talked about SW360 as well. We talked about Trivi, which are security scanning softwares that look at digital identity, digital verification. They look at how the whole source code is built up and so on. So that's a very intelligent tool that's already been there that we can actually leverage from the community perspective. Looking at the DevOps piece, I think most of the tools are pretty similar, pretty known to you guys. I think we start with Node-RED, which is a great tool for us to build OT interfaces, send data out, build even front-end applications just by drag and drop with a beautiful visualization and so on. So there are multiple tools that take us through the entire life cycle of building code to testing code to deploying code. I think these are really cool stuff that can actually help us out if everything works together. So for example, we are a big fan of Grafana and Prometheus that help in data monitoring, visualization, network visualization, how data is getting transferred, and a lot of metrics that come out of it, right? So this is the DevOps rule. At the core is the unified namespace, which is a combination of the message broker that we talked about, a powerful combination of MQTT, which is defined again with a focus through Sparkplug, and also we have Kafka for scaled communication, right? So all of this form the crux where data can go between any of these entities, and any of these entities can, say, publish and subscribe to data and then make the intelligence out of it. So we also have worked with multiple entities on top, which is the actual smart factory box. So we worked with Zabbix, which also takes care of network monitoring, security assessment, what data transfers between each entity within the OT network, and so on. So this is a great tool that we can also, we're not advertising them, but these are good tools that can actually go in, and they are super open source so that we can look at them, work with the community, look at what's happening with the community, and so on. Right, so overall, I think this is a picture that talks about what happens if all of these tools come in together. This is not working today. I'll show you what is working in the next slide. I think this is something that we envisioned for a dystopian future where a smart factory, if it is given to us as a greenfield factory, and if we are able to choose all of them together, and if we build it on open source. The advantages are obvious. You have massive community support. It's free to start with. You can look at how you can interact with developers. The features can be requested and so on. But it's a massive ecosystem play where we are at the forefront where in 2023, there are so many active and live projects that can be used in this domain for smart manufacturing. So moving on, we would also want to showcase what we have done as part of this exercise. So we started working with a small interface for predictive maintenance for a motor. So it started with multiple things. So there are 5 things that we can actually do with a motor. So you can look at an operational data, that is how the machine is running, what is the RPM, what's the parameters, and so on with the controller. You could also use the data from retrofit sensors, IoT sensors with, say, vibration data, sound data, and so on. So we could also have historical maintenance data that we have integrated. And we have also plugged in an energy meter that could help you measure current signature, energy consumption, power factor correlation, and so on. And we also have data from, say, similar performing assets or historical assets that have performed under similar loads, so we know how each of these assets behave. And with this, we applied this thing called DIKW model, which is data, information, knowledge, and wisdom. So with data, you know what you're actually looking at. But then with information, you look at data, and then you correlate with a root cause. So you correlate two things, and then you understand why that is happening. So that is information. And then when you look at corrective actions and real-time response, that becomes knowledge. And then when it becomes wisdom, you can actually predict and look at what would happen in the future, right? So this is the actual setup that we have, and everything is built on open source. So looking at this, I think this can be extrapolated into a smart factory, looking at how assets can be configured and so on. So we have a small three-phase motor at the bottom. We have a voltage meter, a current, energy meter, basically to look at energy parameters, a motor controller, and so on. We have also used Arduino's Opto as a PLC to measure data and then send data out. And we have used all the tech stack that we have described in the previous slide to look at data visualization, data mapping, how energy can be actually sent from a physical object, measured, and then sent out to the cloud to look at real-time performance monitoring, and also look at predictive maintenance. So this is an example of what we can achieve as a community, and this can be then extrapolated to probably a factory as well in the future. Right, so I just want to touch upon this since we talked about the energy monitoring example, because that was a very tight scheduled project where we had to collaborate with multiple OEMs who produce generators, energy meters, solar panels, and so on. And I think that gave us, when we looked at this community, I think it gave us a lot of hope in terms of making this project happen. I think collaboration was the key. And then innovation is a given, because when you talk to a lot of like-minded people, you get different ideas of solving or looking at the same problem. And then you have results with you. And at the end of the day, it is also directly cost savings, because you're not logged into a particular vendor. You don't need to buy plugins that help you sustain your license year on year. I think that's the biggest benefit for us. So when we did a gain to pain analysis, so of course there are pains in the open source model because it's not commercially off the shelf available. Of course there are support options, enterprise options available, but then when you look at free open source software, you need to look at what advantages it gives versus what are the pain points that we have. So analyzing both of them, I think the inertia for change is actually different. It's difficult because you believe, for example, in a endpoint detection response system for an antivirus system, it's very easy to look at a commercial player, but you also have the options for looking at an open source vendor who actually provides you more than what's available, but also gives you the ability to innovate along with them as part of the community, right? So you have obvious advantages like the flexibility that you have, the cost savings, the community backup, and so on. But you also have some inertia and pain points in terms of what's the total cost of ownership, what happens if something fails on a OT environment when there is production running, because production stoppages result to great amount of financial losses. But then at the end of the day, when you start with the DIKW model and also apply with a pilot, start small, think big, and then scale fast, right? I think that's the motto where you can actually test things when they're small and then rapidly scale up once they are working, right? So with this, I think what we have understood is, I think it's the way to go in terms of looking at open source technologies as not alternatives, but then the first choice when smart factories are concerned. And I think there will be a day when a whole new, brand new greenfield factory can be established with open source technologies alone. So just to summarize, Smart Factory, built on principles of open source, unified namespace, report by exception, which is edge-driven, modular, secure, and community-driven, will help you with the vision statement that we talked about in terms of embracing circular economy, minimizing environmental impact, and optimizing resource utilization. Thank you. Thank you, ladies and gentlemen. Open for any questions.
So first of all, thank you very much for the very interesting session. I have actually, in fact, two questions. And maybe you can go one of the first slides. Unfortunately, there are no numbered pages on the slides, but there was one of the first slides where you have like a overview of the architecture. The Greenfield, I think it was pretty much the beginning. Yeah, somewhere there, yeah, it's when you just, exactly. So first question is, when you talk about digital twins, where would you see here the concept of digital twins? Is something that is touching all of these elements, or would you see that it would be positioned in a specific, so to say, category here that you say like planning, manufacturing?
Pretty good question. So I think we also leverage Eclipse Ditto in one of our projects. So I think your question is, where does a digital twin fit in? Because when you look at digital twin, there are different ways of looking at it, a process digital twin or a product digital twin. So it actually connects your product engineering with the actual operations. So it would probably sit in this application box, but that would be modeled by data, and then that would give feedback to your engineering domain. So I cannot box it in a specific domain. But then the easiest way to look at it would be an application that would look at, say, how a particular product is behaving on the field, and then consuming and sending back data to the planning department.
No,
So
that makes sense. So it would be like something like cross domain. No, that's okay. But again, if you, that was the right slide, this would be the second question. If you return to the previous one, where you see the projects.
Projects, okay.
Yeah. Exactly, because we talk about digital twins, and then you mentioned Ditto, right? And you're telling here about the manufacturing or smart factory, so it's like RAD industry, right? And you see here you also have Eclipse Basics, so I assume that you are also using the SM share as a standard for digital twins, right?
That's correct.
Okay. Yes. Yeah. And do you have any experience or recommendations that you can share here about the standard, or using this standard, or is it already being used in one of your projects, for example?
We have not implemented that at a customer location, but then we have played around in our setup to make sure things are running. So we have also leveraged the production dashboard and the facilities that it gives in terms of visualization of data, and then making sure the operations are visible from the production perspective. But we've not implemented it on a customer site yet.
All right, thank you.
Perfect, thank you. Any more questions? Yeah, we've also written a, sorry, Mike. We've also written a book on industrial IoT, so if you guys are interested. Yeah.
More one. You mentioned on the pain side management, but you didn't really, could you please lose a couple of words what that means, that management as a pain when applying open source to this type of projects?
So in our experience, I think what I construed it in a different way, but I think what we meant was management of the project in itself in terms of the feature set that it would give us. I think that's what I mentioned, because for a commercially off-the-shelf product, you have product teams that continuously work on it, but since this is community-driven, we do not know when the feature will be available, for example. Yeah.
Is your data ingest IoT platform in the cloud? I haven't seen this, or maybe I missed it.
Yes. So we took a dual approach, as we talked about as well. So in terms of making sure what stays at edge in terms of real-time compute, real-time action, decision making, and so on. So we also leveraged AWS, for example, in terms of hosting the data back into the cloud. So edge first for decision making, localized decision making. Then for high compute, say running your machine learning models in terms of, say, running predictive maintenance model, I think that is implemented on the cloud, on AWS.
Yes, another question. First of all, thanks a lot for the presentation. It was quite extensive to get all these different technologies, let's say, in the right order in all the boxes to be filled. That's pretty nice. One aspect I was still maybe missing, or maybe I just missed it myself, is how do you deal with the different data semantics and the exchange of data, like service discovery or finding the different available software components that you were talking about? Is it all through MQTT, or is there some other approach underlying?
So currently, I think what we leveraged was the framework that MQTT provides in terms of data exchange from machines to the compute units or the applications. But then when you talk about different systems, say ERP or production planning or say design planning, I think they'll have different ways of data exchange, obviously not with MQTT. But then the idea is to have a digital service bus or the unified namespace with which it's easier for everybody to access data. But I think there would be APIs that would be there to exchange, say, design data, production data, ERP planning data, and so on. But then we have not integrated with the outside block, the blue block, when we talked about ERP and so on. So I think those we do not have, say, I mean, at least I'm not aware of open source alternatives that are there in that domain. Yeah.
Okay. Thanks.
Thank you.
Any more questions?
All right. So thanks again. Thanks everybody for turning up, and thanks again.